Alright, welcome back to the second video on probability for JC math, and we're going to be talking about Venn diagrams. So Venn diagrams is something that you have encountered in secondary school, but I'm going to use this opportunity to teach you a golden thought to approach Venn diagrams, right? Because typically what most people do is they will try to memorize the different shapes, the different colorings, right? The different orders of Venn diagrams. But honestly, you don't need to do all that, right? All you need to do is to know how to analyze Venn diagrams, and you'll be able to figure out any single Venn diagram in the whole world. I'm going to teach you that in this video. Okay, so let's look at this first. What's a Venn diagram? Let's define what's a Venn diagram, right? A Venn diagram is just a way to physically show the distribution of event spaces. Okay, is within the sample space. Okay, that's a very simple way of putting it. So let's just use an example to make this even clearer. Right? For example, let's say my sample space is the dice, right? Like I roll a dice, for instance. So it'll be 1, 2, 3, 4, 5, 6 over here. Now, typically, sample space, we will also usually call this our universal set, right? Because it's the set, right? Sample space. So sample space is universal set because it contains all the different possible outcomes, right? So the reason why I call this universal is because it contains all the different possible outcomes of the experiment. So yeah, that's why it's called universal, and it's a set. That's why I call it universal set. So this over here has a symbol, and it looks something like that. Okay, my drawing is not the best, but it basically like a reverse tree. So reverse tree, they draw one line up. It just shows something like that. So typically our universal set will look something like that, right? And then our elements will be all over the place in the universal set. So for instance, let's say I have 1, 2, 3, 4, 5, 6 over here, right? They're all just floating around somewhere. Now, an event space depends on what the event is, right? So for example, let's say my event is numbers that are less than or equals to 3, right? So for example, like that, less than or equals to 3. So very clearly, I can see that this over here forms one event, right? And then let's say this event over here is event A. So event A, right? Event A is numbers that are lesser than or equal. So over here, I will label event A over here. Right now, let's say I have event B, or I can say it's A prime because it's the opposite of A, is numbers that are bigger than 3. So over here, this is my event B over here, right? So you can see that the Venn diagram allows us to physically see the sample space and also how the event space actually fits into it. So, right? So far, all this is something that you are probably encountered before. So now, how do we actually label Venn diagrams? How do we actually read Venn diagrams? For example, if I have something looks like that, right? P union B prime, right? Something like that. So how do we actually go and enumerate this, right? How do we actually figure out what elements belong to what? So to actually make this example a little bit clearer, I am going to expand the sample space, okay? So let's say I'm going to include 7, 8, 9 over here. And then I'm going to change this condition to more than 3 and less than or equals to 6. Okay, so yeah, so far everything is still correct. But now I include 7, 8, 9. That means 7, 8, 9 are going to be outside over here. 7, 8, 9. 7, 8, 9 are going to be outside of A and B because 7, 8, 9 do not belong to A. So if let's say I have something that looks like that, right? A union B. How do we actually figure out what elements belong to A union B? Now, A union B means event A and event B, right? No, sorry. This is all. So event A or event B. Now, whenever you have Venn diagrams, the trick is to the regions that you want. So event A, I take event A. And event B, I take event B, right? And since this is all means I take both regions. That means essentially anything with one tick. So the total event space would be, I have 6 elements, right? 1, 2, 3, 4, 5, 6. So 6 elements out of total 9 elements, and therefore I get a probability of 1 over 3. Now let's say I have something that looks like that, right? Let's say I want A intersect B. A intersect B means I want event A and event B. So if I want event A and event B, means that these two must happen at the same time, right? I'm just going to show you. And in the context of Venn diagram, if you want both to happen at the same time, that means both of them have to intersect, right? They must overlap in order to happen at the same time. But we can see that from the diagram over here, event A and event B do not overlap. And therefore, there are 0 possible outcomes that have both out of 9 different possible. And therefore, the probability is 0. And this is what we call an impossible event. Now, if I were to use, let's say this is event A and event B, right? Event A, if I were to pick it, will be this portion here and the blue color portion over here. You just erase all this and then here, right? And therefore, event B will be here and here. So you realize that the portion that they overlap will have 2 ticks. And therefore, when we tick it like this, it's very easy for us to see where are the portions that they overlap. So where they overlap is where they have 2 ticks. And you will always take 2 ticks when there is a N over here, right? When there's an intersect over here, because you want both ticks from both events. Okay, so this is the idea behind Venn diagrams. Again, it's not something new, it's just more so of a recap. If you want a more comprehensive recap, a really more beginner style recap, go watch my secondary school probability explanation on this channel over here, right? If not, we will actually tackle this question over here, right? So feel free to pause this video to actually try this out for yourself. If not, we'll run through the question together right now. Okay, so we have this over here, and we have event B such that event A is 0.3, event B is 0.4, and union B is 0.5. So what does this look like in practice? So I'm going to draw my universal set over here, and over here we have 2 events, event A and event B. Now, how do I know that they overlap, right? It's very simple. You see that event A union event B is 0.5, but event A itself is already 0.3. And event B itself was already 0.4. So let's say if they don't overlap, right? This over here should be PA plus PB, right? And I should be technically getting 0.3 plus 0.4. I should technically be getting 0.7 if they don't overlap, which means that if they don't overlap, I'll be taking 0.3 here plus 0.4, and that will give me 0.7. But we can see that over here is 0.5. And since the value is lower than what we actually expect, that means they overlap. There'll be some regions that they overlap, and therefore the value is not 0.7. So that's why we know that the whole thing here is 0.5. So let's say this is 0.3, then here will be x, and then here will be 0.4 minus x over here, right? And we know that this whole thing over here will give me 0.5, right? And it kind of makes sense, right? 0.3 minus x, and then 0.4 minus x, the whole thing gives me 0.5, right? Because the x is the common factor, right? And then if you just look at this over here itself, this is 0.3 minus x plus x will give me 0.3. And then this portion over here would be 0.4 minus x plus x, which will give me, right? And then it just fits whatever we have. So the x over there is a variable that we need to solve for. So let's solve for x, right? If I have 0.3 minus x plus 0.4 minus x, right? Now I'm just adding the 3 different regions. 0.3 minus x is here, then I plus x over here, then I plus 0.4 minus x over here. It gives me this whole line over here, right? And when I add all them together, I get a value of 0.5. So here I get 0.7 minus x plus x minus x give me 0.5. So 0.7 minus x is 0.5, and therefore x is 0.2. So I solve the x is 0.2, and therefore here I'm able to re-annotate this, right? So I'm just going to re-annotate it over here to give me a more comprehensive understanding of what my Venn diagram actually looks like. So here's A, here's B. So 0.3 minus 0.2. So I know that on this portion over here, I'll get a value of 0.1. Here will be 0.2, and then over here will be 0.12. Right, and the whole thing adds up to 0.5. So you can see that everything actually makes sense. Now with that said, we know the values already. We can proceed to solve the question. So A intersect B, right? I'm going to take the region of A first. So I take here, then B. I take here, And since this is intersect, I will take the portion that has both ticks, right? Which will be this portion over here. So it's P A intersect B, and I'll get 0.2, right? Because 0.2 is inside that region over there. Next, for A intersect B prime, very simple, right? I just need to make sure that I tick all the regions. So A is here, the red ticks, and then B prime is anything outside of B, right? So this one is anything outside of B. So outside of B would be here and here, right? And now you realize if everything over here is 0.5, what does that mean about everything outside? Everything outside will be 0.5 as well. So over here I can annotate 0.5, because we know the outside plus inside, everything will add up to 1. Right, a probability of 1. So since this intersect, that means I want 2 ticks from both regions. So you realize that in which region actually have both ticks? It's actually only here, right? Because you see, for the red ticks, only this portion over here got 2 ticks. So this portion over here would be A intersect B prime, which will be 0.1. Last but not least, we have this A prime. So A prime would be anything outside. So it will be here and here. And then B would be here and here. Now, 1.1 is union. And union basically means anything with one tick, right? Union doesn't mean we need to overlap. It doesn't mean that we need to overlap. It just means that we take everything that has a tick. And therefore, you see that everything that has a tick in it would be this portion here, the 0.5 here, the 0.2 here, and the 0.2 here. So all these give me my final answer over here, which is A prime union B, right? And I just need to add everything together, which should be 0.5 plus 0.2 plus 0.2. I get 0.9. That's the final answer to this question over here. Okay, and that's it. That's it for this Venn diagram question. Relatively straightforward. Let me know if you've got any questions in the comments below. Otherwise, I'll see you in the next video for the next concept. And that's where we actually start going into the JC curriculum proper with more concepts coming your way. Okay, if not, I'll see you in the next video.